Hello and welcome back to Python. In this video, I will explain about Numpy Python library. Numpy is a Python library to work with arrays. So for that, we have to import a library. Import Numpy. You can use a keyword called as, and Numpy can be written as NP instead of Numpy. So I'll take it as NP. So throughout my program, instead of using Numpy, I can use a word called NP, right? NP. Now, so arrays can be 0-dimensional, 1-dimensional, 2 and 3-dimensional arrays. So let us see how to initialize different types of arrays. So for 0 dimension, I think we can use array is equal to NP dot array. Or you have to give a number because it has only 0 dimensions. Print array shifted to so this is 0-dimensional, right? 0-dimensional. Now coming to the 1-dimension array, we can write array is equal to NP dot array. So 1-dimensional array must be enclosed in square brackets. Now we can give 10, 20, and 30. Now you can print the array. Print array. So this is a 1-dimensional array. How to initialize the 1-dimensional arrays. Now coming to the 2-dimension arrays. With this. And then for 2 dimensions, use comma and then use other square brackets and give numbers 40, 50, and 60. So this is, you have to give square brackets. So for the initialization of 2-dimension arrays, we have to use another square brackets, and within the square brackets, we have to use 2 square brackets with the numbers. So this is a 2-dimensional array. Now coming to the 3-dimension, we can construct 3-dimension with 2 dimensions. So first we'll write it as 2-dimension array. Let's see how to initialize a 3-dimensional array by using 2-dimension arrays. So copy this, and then we have to use 2-dimension arrays for the creation of 3-dimensional arrays. And then change this, use one more square bracket. Change the numbers so that it is easy for you to identify the arrays. That's shifted. So this is the 3-dimensional. So this is how we have to initialize 0-dimension, 1-dimension, 2-dimensional, and 3-dimensional arrays. There are certain methods that can be applied onto the arrays. One is called indexing. So let us go over the indexing. Now take a 1-dimension array. And we'll see the indexing. So we can write array of indexing is with respect to the places So this is zeroth position of the element, first and second. So 0. So 10. So indexing is possible. And this is called indexing. You can give the positional value on display. So indexing is possible. So this is called indexing. And then slicing is also possible. So take the same query, add few more elements to it, and then we can slice the elements. I want to slice 1 and 2. So this one 20 and 30. So let us see. Right. So this is 0, this is 1, and this is 2. So starting with 1 and ending it n minus 1. So that means only 1 will be displayed. I'll change it to 3 so that we get 2 elements. Right. So slicing is possible. We can also consider give the starting until the end. So starting from the second element to the end, we can print. So this is 0, first, second, so 30, 40, 50. Similarly, we can also give from the beginning, so to the end, to the third element. So we'll display 3, 10, 20, and 30. So 3 means n minus, so 3 minus 1 up to 2. So 0th element, first element, and second. This indicates, the colon indicates starting position. So here it indicates the ending position. So from the starting to the element, from the beginning to the end of the second element. And here from the second element to end element. In the array we can use, this is called slicing. So slicing is also possible. Now we can connect the arrays. Suppose arrays are constructed by using either integers or floating point numbers. We can convert from one data type to the other data type. Let us see what is the how to change from one data type to another type. So now I'll consider an array of floating point numbers 1.1, 2.0, 3.1, 4.0, and 5.1. Now I want to convert this to integer data type. So for that you have a method called as type. So take another variable x is equal to a. So we are changing the array to as type. This is a method to change data type as type to integer. So give it as I. Now print x. So it has changed the floating data type to integer data type and has printed it is integer type. Similarly, we can convert into Boolean type also. So you take array is equal to np dot array of 2, comma 0, comma 1. I'm taking these 3 elements. I want to change the data type of the elements to Boolean. So let us see what happens. Array dot as type, and within the brackets write bool, and then print x value. So it will represent the numbers, integers into Boolean data type. So 2 is true, 0 false, and number 1 is true. So this is a Boolean data type. So this is called as type method to change the data type. Right? So this is called as type method to change the data type, right? And then there is a method called copy. You can copy the elements. That is, you can change the array. Now let us see how to change it. Consider array is equal to np dot array of numbers 10, 20, and 30. So I'll copy to x. X is equal to a dot copy. Let us see whether we are able to print it or not. Array dot copy. So there is a method called copy where we can copy the elements of array to another variable. So that is called copy. We can change the array. And let us see whether we can change the elements of the array. So this is a copy method. Now let us try to change the arrays and see by using new method. So array is equal to np dot array of 10, 20, 30. X is equal to a dot view array dot view dot a array dot view and a array of 0 is equal to, suppose I consider as 1. Now print array as well as x. So now see the element is 0, element is being replaced with 1. So we can print, we can also print, we can use print option, print array. First we'll print the array. Yeah, next print x also. Print, when you use print option, print x. Now here also we can use print options to print the array. So if you write print of x, then it will print the array. If you print x if you print, then it gives array and integer type. If you print, then it will print only the converts floating numbers to integer type and prints the values. So here also we can change, use the print option. So that will print only the array instead of printing array of some element. So we can use print of x. So this is a view option. So it changes both arrays. Copy only copies. Here we can also change the values of both arrays. Right? So that is called view method. And then if you want to know the dimension of any array, you take any array and let us see what is the dimension of that array. I'll take this array. Okay. Now we can use a method called print array dot shape. So it gives the dimension. So it is 2 by 3. So to know the dimension, we can use a method called shape. Now we can also reshape the arrays. So for that, consider array is equal to np dot array of, and take the elements 1, 2, 3, 5, 6, 7, 8, 10, 11, and 12 elements, and I'll reshape this one to new dimension. So for that we have array dot reshape. You can give the dimensions how to split the array. I'll go with the 4 by 3. Then print the new array. Now it has to print, see, 4 by 3 array. So this is how we can reshape the array. So we can take the one dimension array and reshape it to other dimension arrays. So this is 4 by 3. We can also use the iteration. So take this array. Iteration is also possible. So for and use for I in a in the array, print I. Let us see what it prints. So it has printed each and every element in the array. So you can use the print option. Now we can also use a method called concatenation. So take two arrays, array 1 as np dot array of 10, 20, 30. Array 2 is equal to np dot array of 11, 12, and 14. And for the concatenation, we can use the method concatenate, n is equal to np dot concatenate. We can use within the brackets give array 1 comma array 2 and then print the new. So the concatenation is also possible. Now we can split the array. We have it as method called split array. So it adjusts the elements from the ending. So let us see what is that. Array is equal to np dot array of 1, 2, 5. Split it. So instead of reshape, we can also have use this method np dot array. We want to split array 2, 3. So we'll see what it does. Print of x. So we have to use a method called split. Say we have a method called splitting where it splits the array and edges the elements from the end according from the end. So we asked to split the array into 3. So from the end it starts adjusting. So for 1, 2 will consider as one array, 3, 4 as a second, and 5 as the third array. This is called splitting method. So an array underscore split. And there is a such method. Suppose we consider an array of suppose I take 25, 27. Yeah. So in the searching, we can use the method called where x is equal to np dot where we can write array divided by 2 is 0. So it will take only those elements is 0. So print x. So the others will be ignored. So divided by 2. So array divided by 2 is equal to 0. So it will consider only it's a search method. So where is a search method where it will tell you the elements which are divided by 2 and which position they are, that is 0, 1 and 2. Suppose I can also search like this. We write where array is equal to, instead of division, we'll go where array is equal to 35. So I'm searching for a particular element. So it gives it is in the third position. So this is called searching. Now we have, after searching, we have the sorting method. So take the array and then sort it. We can use print np dot sort method of array. So we'll print the array after sort. So this is called sort. And then we can create an identity matrix. Let us see x is equal to np dot identity of 5. So we'll print x. So it will create an identity matrix. Let us see if it creates. So it creates an identity matrix with 5 by 5 dimension. We can also create an matrix with the zeros, np dot zeros, and you have to give the dimensions 2 by 3, and then print x. So it gives a 2 by 3 array, 2 by 3 matrix with the zeros, and also we can go for ones also, same. Let us try with the ones. Yeah. And we can also give the type of the integer in the arrays while. Yeah. So integer np dot ones, I change the dimension as 3 and 2, and the data type as d type as integer 32. Let's try to do this. So 3 with 3 dimension and 2 by 2. So this is zeros, and all the operators, arithmetic operators also we can use on matrix. Let us create a matrix first. Right, and then if you write print, we'll see what happens. Array plus 2. So 2 should be added to each element in the array. Similarly, we can go with the multiplication, division, power, everything. We can use all the operators we can use. Minus 2, yes, into 2. So all the arithmetic operators into, let's start, right? Similarly, the division and the power also we can do. We'll just try. Divided by 2. Right? And then we'll also consider the power of 2. So for power, you know the symbol is double star. Yes. And we can take 2 arrays and also find the sum. Array 1. And then array 2. We can add array 1 plus array 2. Yeah, you can use print option if you don't want to print as array. It's an array type. You don't want to print, you can use print option. And then we can also have the cost values for the array. Suppose array is equal to NB dot array of, we give some values 0 and 1, and then put it in the square brackets. Now x is equal to np dot cos of, we can take the array, we'll find the cos, and then cos of those values. So print x, yeah, cos 0 is 1, cos 1 is 1. Similarly, we can find the maximum, minimum values in the array and sum of the array. That is, check those methods also. So print np dot maximum of array 1, print np dot minimum of array 1, print np dot sum of all the sum of particular array 1. So maximum is 37, minimum is 10, sum is 159. So we can also find the square root, the standard deviation. Let us search it, those methods also. So print np dot square root of array 1. So for each element, you can find the square root. You can also find the standard deviation and logarithm also. SDD, standard deviation of the elements in the array. So this is standard deviation for the elements in this array. Similarly, you can find the logarithmic values of the elements in the array. So just you have to use log 10 array to the base 10. So we get the elements. And then it is also possible because we can construct two-dimensional arrays. It is possible to find matrix sum, multiplication, addition. So let us create two matrices. Array 1 is equal to array of. You can take a two-dimensional matrix. One, two, three, four. So this is array 1, 2, 3, 4. And array 2 is equal to, I'll just take the same array. And then I'll change it to tens. 10, 20, 30, and 40. Now I want to find the sum. So print array 1 less array 2. Let us see what happens to this. So it has added summation. Also use the multiplication. So use a star and then print. So 10 into 1, 2 into 40. Matrix multiplication is also possible. Instead of this, we can go for matrix multiplication just like a matrix. Here, instead of using this, you can use array dot of array 2. Then it will give you the output as an array multiplication. So array multiplication is also possible. So the method is dot array 2. So it performs matrix multiplication. So these are some of the methods that can be applied in the arrays. So the first thing is how to initialize the arrays, 0 dimension, 1 dimension, 2 dimension, 3 dimension arrays. And the methods that they are applied, indexing is possible, slicing is possible. We can change the data type of the elements in the array by using as type. And then we can copy the elements to another array. And then we can also change the values and change the values in the two arrays. So I have used array and X as its second array, and then change the values for the first array. And if we print, we get the values also to be changed in the X and X also. So X also gets changed. And then we can shape the size, and then we can reshape the array, and then we can put all the elements of the array. Iteration is possible, concatenation is possible. Splitting, we can split the elements into different arrays, and then you can use the search method by using where, and you can sort the elements in the array. We can create a matrix, identity matrix, 0 matrix. That is array matrix with zeros, matrices ones. And then we can create a dimension. We can also set the dimensions of an array, and all the arithmetic operators can be applied to arrays: plus, minus, multiplication, division, power. And we can add two arrays. We can find cost of each element in the array. We can find the maximum element, minimum element, and sum of the elements in the array. We can find the square root of each element in the array. Similarly, the standard deviation of the complete array of the elements, logarithmic values of each element in the array. We can add two arrays. Multiplication is possible, and matrix multiplication is also possible. I hope you understood the introduction to Numpy, that is a Python library for arrays. Thank you.